So now that ARP is complete, PC1 is going to prepare the ICMP echo request. So it's going to build the packet, right? So it has a source, destination, it has the source IP, it has the destination IP, and then it has a source MAC and the destination MAC. Right? So the packet is sent out through the PC1's network interface to the switch, right? The switch checks the destination MAC address. Since it already knows the port for that MAC address, it's going to go ahead and forward the ICMP echo request to PC2, right? So we're now at the ICMP echo request, right? So PC1 right? PC2, it's the switch. So it knows the MAC address now of PC2. So it's going to prepare the ICMP echo request, right? So prepares it, it's going to send it out through the switch, and then the echo request is going to be received by PC2, right? And then we're going to prepare ICMP echo reply, right? And then, so I'm going to highlight this. Let me do this a little bit bigger. I'm going to highlight this. Right, so that's the ICMP echo request. And the ICMP echo reply, that's going to come from PC2. Right? So that's going to come from PC2. Let me go ahead and highlight that green. Right? It's going to come from PC2. Right? So PC2 receives the echo request and processes the echo request. It prepares the echo reply to send back to PC1. And this reply is going to include its source IP, right, which is 192.168.125, destination IP, its source MAC address, destination MAC address, and it's going to send that to the switch. The switch is going to receive the frame, and it's going to check its MAC address table, and it already knows the port, right, where PC1's MAC address, so it's going to forward it, right, to where that PC1 is connected to. Once the echo reply is received, it's going to, the echo reply is received by PC1, right? It's going to accept the reply. It's going to recognize it as a response to its ping. So the ping is going to be marked successful, and then you're going to see a confirmation message in the command prompt that the ping worked, right? So too long, didn't read, right? Ping from PC1 to PC2. Quick summary. So PC1 checked the ARP table. If the MAC address is unknown, it's going to send the ARP request as a broadcast message. The switch is going to flood the ARP request, and it'll learn PC1's MAC and port. PC2 will receive it. It's going to reply with an ARP reply. The switch will learn PC2's MAC address and the port, and it's going to forward the reply to PC1. PC1 will update its ARP table. It's going to send the echo request to the switch, and the switch will forward it to PC2. PC2 is going to reply with the ICMP echo reply, and then it'll send it to PC1, right, the switch, and PC1 will receive the reply, and the ping is successful, right? So when devices in the same subnetwork, right, same network, no router is needed. They communicate directly, and this communication happens in the layer 2 data link layer, and it's using the MAC addresses. So ARP maps the destination IP to its MAC address, and MAC addresses are stored in the ARP table for faster lookups. The switch builds a MAC address table as it learns which devices are on which ports. Once the MAC address is known, the switch forwards frames based on the destination MAC address.